Now we will discuss about the brightness of the star. Stars, you know that in general greatly differ in brightness from one another. As we observe the sky during daytime, we cannot see any other stars in the celestial sphere because of the brightness of the sun. When sun is set, we can see all the rest of the stars and celestial objects in the celestial sphere, where still we can have the stars having lesser brightness and higher brightness. The most brightest star which we can observe is the Sirius actually. Anyway, we can have varying brightness of stars in the celestial sphere or in the heavens during the night. Now, to represent this brightness of the star, we will use another term which is called the magnitude. So, the magnitude of a star is a measure of their brightness. So, magnitude means it represents the brightness of the star. This magnitude we can have two types, the apparent magnitude and the absolute magnitude. We are on earth and we are observing the heavens in the night so that we can see the stars at different having different brightnesses, but we cannot say that it is the actual brightness of the star. If you consider the brightness of the star, some stars are much brighter than the sun, but what we are observing is that where the sun is the most brightest of all stars. So this thing, that is what we are observing, which is not the actual one, is called the apparent magnitude. So we will discuss these two, apparent magnitude and absolute magnitude, in detail during this lecture. So just as an introduction, apparent magnitude is the brightness of the star as we observe them. Absolute magnitude actually represents the exact brightness of the star or the actual brightness of the star. So apparent and absolute magnitudes are different. Sometimes if you consider the apparent magnitude, some stars will feel that it is brighter, but if you consider the absolute magnitude, that brighter star which is having a greater apparent magnitude may be having lesser magnitude or brightness. So let's discuss these two things first, that is apparent magnitude and absolute magnitude. It is a common fact that we can observe some of the stars with a naked eye. The brightness of the star thus appears to us is called the apparent brightness of the star. This is represented by apparent magnitude. That is, apparent magnitude of the star denote their brightness as we observe them. This brightness actually depends on the actual or the intrinsic luminosity as well as on the distance of the star from us. So the apparent magnitude of a star actually depends not only on its actual brightness or the intrinsic brightness, or which we actually the brightness is the amount of energy radiated by that star, that is called the luminosity. So the actual energy radiated by that star is the luminosity. So it is the apparent magnitude not only depends on the intrinsic luminosity but also on the distance of the star from us. So the apparent magnitude is usually represented by the small letter m. So remember this representation, Small letter m means it is the apparent magnitude of the star. Apparent magnitude means it is the magnitude brightness of the star as we observe them, or the brightness that appears to us is called the apparent magnitude. Now, based on this apparent magnitude, we can classify the stars into different catalog, and the first one in this one is done by Hipparchus during the 2nd century BC. He classified the stars according to their apparent brightness or apparent magnitude and catalogued about 1,000 stars into 6 groups. That is, each group is having a particular magnitude, and he denoted the first group as first magnitude star, the second group as second magnitude star, third group as third magnitude star, and up to 6 he named as 6 magnitude star. So, based on the apparent magnitude, Hipparchus classified thousands of stars into 6 groups. The first magnitude group contained the brightest star, the second magnitude contained the next bright one, and the third magnitude star contained the next bright one, and so on. So, in this system, the faintest visible stars were contained in the 6th magnitude group. A similar magnitude scale was also used in the Ptolemy's catalogue in the 2nd century AD. In about 1830, William Herschel, by his experiment on stellar photometry, determined that a star of first magnitude was about 100 times brighter than the star of 6th magnitude. According to Ptolemy's classification and Hipparchus' classification, the brightest star in the first magnitude group and faintest visible star in the 6th magnitude group. But Herschel found that the first magnitude group stars are 100 times brighter than the 6th magnitude groups. That is, the faintest visible star, the brightest star in the heavens is 100 times heavier, brighter than the faintest visible stars in the heavens. Later in 1856, N.R. Pogson constructed the quantitative scale on a precise basis. That is, the actual star catalogue was on the quantitative scale was put forward by N.R. Pogson. This catalogue means it contained the name of the star and their properties. The first catalogue was designed by on the magnitude basis. That is, on the basis of the brightness of the star. First catalogue was designed by Hipparchus during 2nd century BC. But in 1856, N.R. Pogson constructed this on a quantitative scale. He defined the magnitude scale by taking the ratio of the brightness of first magnitude star to that of the 6th magnitude one, exactly 100:1. That is, if you consider brightness of the first magnitude star, let's say B1 represents the brightness of the first magnitude star, and B6 represents the magnitude brightness of the 6th magnitude star, then B1 by B6 is 100/1, or B1 is to B6 is equal to 100:1, which is done by N.R. Pogson in 1856. Also assumed one thing that the ratio of brightness would give equal differences in the magnitude. That is, If you consider a B1 class has a magnitude M1 and B2 class has a magnitude M2, then equal ratio of brightness, that is B1 by B2, would give equal difference in the magnitude, that is M2 minus M1. So this is another assumption made by N.R. Pogson, that is the equal ratio of brightnesses would give equal difference in the magnitude. So to discuss it, let's consider B1 and B6 denote the brightness of two stars which are of first and sixth magnitude respectively. Then B1 by B6 is equal to 100. Also, if you consider the ratio of brightnesses of the adjacent stars, that stars in the adjacent groups B1 by B2, that will be same as the brightness ratio between B2 and B3, which will be same as B3 by B4, which will be same as B4 by B5, which will be same as B5 by B6. So the ratios of the brightness of two stars which lies in the nearby groups will be the same. So in that way, if you consider B1 by B6, we can write it like this: B1 by B2 into B2 by B3 into B3 by B4 into B4 by B5 into B5 by B6. It will be same as B1 by B6 because B2 cancels, B3 cancels, B4 B5 B5 are cancels. What remains is B1 by B6. But B1 by B2 will be equal to B2 by B3, which will be equal to B3 by B4, which will be equal to B4 by B5, which will be equal to B5 by B6. So if you put this value as X, these are all equal, that I am putting as X, then this will be X, this will be X, this will be X, this will be X, this will be X. So it will be X into X into X into X into X, which is equal to X raised to 5. That's why I am writing B1 by B6 is equal to X raised to 5, which is equal to 100 by 1, that is equal to 100. According to Pogson's assumptions and observations, he showed that B1 by B6 is 100. So X raised to 5 is 100, then we will get X as fifth cube root of 100, that will be equal to 2.512. That is the ratio of brightness of two stars whose apparent magnitude differ by unity is 2.512. Now, if you consider Bm and Bn, where n greater than mb, the brightness of two stars having the magnitude m and n respectively, this m may be 1, 2, 3, 4, 5. If m is 1, then n will be 2, 3, 4, 5, 6. Or if m is equal to 2, then n will be 3, 4, 5, 6. If m is equal to 3, n is equal to 4, 5, 6. If m is equal to 4, n is equal to 5 and 6. If m is equal to 5, n is equal to 6. All any of these combination. So I am assuming that two stars they are having the brightnesses Bm and Bn having the magnitudes m and n respectively. Then Bm by Bn can be written as 2.512 raised to n minus m, Bm by Bn. So now if you take log on both sides, then you will have log Bm by Bn is equal to n minus m into log 2.512. Now this will be equal to this will be equal to 0.4 into n minus m. Log 2.512 is 0.4. Now take the antilog of this LHS, you will get Bm by Bn is equal to 10 raised to 4.4 into n minus m. It shows that higher the magnitude of a star, the lesser is its magnitude, and vice versa. So this is another important relation regarding the brightness and magnitude of the star. The ratio of the brightnesses of two stars with brightnesses m and n is given by Bm by Bn is equal to 10 raised to 0.4 into n minus m, where n is greater than m. The magnitude of n is greater than m. Now if you consider the Venus, which has a magnitude of minus 4.4 and the Sun has a magnitude of minus 26.8, then the brightness of the Sun can be written as, if Bs represents the brightness of the Sun and V represents the brightness of the Venus, then Bs by Bv is equal to 10 raised to 0.4 minus 26, n minus m, n is minus 4.4 minus 26.8, which will be equal to 9.12 into 10 raised to 8. So the brightness of the Sun is equal to 9.12 into 10 raised to 8 into brightness of the Venus. So remember that this brightness is the apparent brightness of the star. So that's all about the apparent magnitude of the star. Now we have to discuss about the absolute magnitude of the star, that we will discuss in the next lecture. Thank you.